Really easy to teach this subject to you because you are engineers, so and you have done fluid mechanics at some point. But if you have not done it, so I hope that you will still try and grasp what we're gonna talk about. So it's only so what you need to understand is only what is on my slides actually in order for you to understand wind turbines. Okay. Anyways, so what is a wind power? As I've defined, so as per definition that I've given here, so wind power is nothing but the kinetic energy of wind that has been converted uh, into electrical energy. Basically, if I have wind coming, so this is wind, okay, it comes at a particular velocity u naught, okay, so which means then that it has kinetic energy, it comes at kinetic energy k naught, okay, and of course it will find my wind turbine here. So this is my wind turbine. So I will explain to you in details how the wind turbine works, okay? So just for now, know that at this point, there's a wind turbine, okay? So then when this wind reaches the wind turbine, the kinetic energy of the wind is now converted by this turbine to electrical energy, okay? So basically, the wind turbine, what it does, it takes the kinetic energy of the wind and then converts it to electrical energy that we can use for our appliances. But of course, it does not actually convert all of the kinetic energy. So which means that so once the wind kinetic energy has been absorbed, the wind still continue to move and pass the turbine with a new kinetic energy Kf, which is less than K naught, which is less than the kinetic energy before wind interact with the turbine. So only a particular friction of this energy is converted into electrical energy. Okay. However, in order for us to understand how wind turbine works, so we need to fully understand some fundamentals of fluid dynamics. Okay, what happens when fluid flows? What is the physics behind? So, because of course, so air is a gas, and of course, a gas is fluid. Therefore, the physics of air or of wind, so we can understand it based on the fundamentals of fluid dynamics. Okay, so we need to then recognize the fact that there are two ways in which wind can flow. Okay? Two ways in which fluid can flow in general. Let's say just say fluid in general. So it can flow in two ways. The first one being the laminar flow, while the second one being the turbulent flow. Okay. So now what is the difference between the two? The difference is straightforward actually. The difference is that, so when you look at the laminar flow, it is regular. The laminar flow is regular. It's a regular flow. Regular flow. What do I mean by that? I mean that, so if, for example, I have a fluid particle right here, I can actually, in principle, for every fluid particle, I can trace its path as it flows from left to right. I can trace its path. Okay, it is a smooth path. Okay, I can trace it. And if I have another fluid just below, fluid particle just below it, I can also trace the path of this other fluid element. Okay. However, even if I can trace it, but the most important property of laminar flow is that, so these two fluid particles, they do not move across different paths. So this path, each path, so we call it a streamline. Okay. The streamline, it's used to visualize the path of fluid particles. Okay, so this is a streamline, that's another streamline, and of course you cannot find streamlines crossing each other, because fluid particles in laminar flow, they do not cross each other. So it isn't more like an ideal flow. Okay, so but of course, so now if it happens that so these fluid particles, they're moving at a high speed, or they meet an obstacle. So let's say that's an obstacle such that so their velocities change abruptly. So it means that so now, for example, you'll have a fluid particle moving on the streamline on top, but so if you look at the one below, so if it happens that, so let's say that its velocity is being changed abruptly by this obstacle, what will happen is that it should change the direction. For example, so they keep changing the direction when they meet, for example, an obstacle such that so the streamlines are no longer smooth, almost straight lines, but now they form what we call eddies. Okay. So they are more like spiral shapes. Okay. Of course, these spiral shapes, they happen at different sizes, and we call them eddies. Okay. So basically, what you see is then that so these spiral shapes of fluids or structures of fluids will point a different direction, which means that so fluid elements will have different velocities as compared to the laminar case. And of course, so you cannot predict exactly where they are pointing the velocities. That are basically random velocities of your fluid elements. Okay? So what I've actually explained here on this point is that so basically, so the fluids are moving in random directions. In other words, the flow is chaotic in nature. Okay, so the important thing actually that you need to fully understand, at least the basics about the difference between the laminar and turbulent when it comes to wind turbines, is the fact that so what you'll see on the turbulent flow, the overall kinetic energy of your fluid will be then lost as thermal energy. Okay, so the fact that so initially we had the fluid moving at a particular velocity, which means that so it has particular kinetic energy. So the fact that after reaching, for example, an obstacle, now it becomes chaotic. In other words, it should be slowed down when you look at the direction towards the right. So the direction towards the right should be slowed down, because some of the kinetic energy now is used, for example, to interact with other particles and moving backward and chaotic in nature. Therefore, this is what we call thermal energy, of course, of the fluid elements inside. Okay, so basically the important thing is that the kinetic energy is lost as thermal energy when you're looking at turbulent flow. And this is very important actually when we're looking at turbines, wind turbines. Okay. And when you look at wind turbines, you always want to make sure that so you try and minimize turbulence as much as you can. Okay. So turbulence in wind turbines is an enemy. It should be avoided or minimized.